I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, March 27th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Looking at significant wave heights for the North Pacific Ocean, we see a gale off California producing 26-foot seas aimed off to the southeast, actually targeting Southern California pretty well, and previously targeting North and Central California. Also, remnants of a gale starting to fade over the dateline with 22-foot seas, and maybe another system trying to organize over the Kuril Islands. So winter is not done with us yet. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough, a dip in the jet, just like that right there. That helps create a counterclockwise flow aloft and down at the ocean's surface, and that is the hallmark of low pressure in the northern hemisphere. And of course, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, generate seas. Seas, if they're high enough, as they radiate away from the fetch area, turn into swell. Swell, when hit your beach, turns into surf. So we have the jet pushing off Japan, consolidated with winds at 150 knots, ridging up into the Bering Sea. There's the Aleutian Islands right there. Then falling south into a trough just a little bit east of the dateline, ridging again almost up into Alaska, falling south yet again, forming another trough, supporting low pressure off of California, then finally pushing into the U.S. West Coast. All right, so two potential areas of interest. So we get into Monday. The first trough here off California starts moving onshore. The second trough starts pushing into the northwestern Gulf. Still continues on, but starts getting pinched. Probably not too supportive of gale development. But as we get into Tuesday evening, a new trough starts building over the dateline, being fed by 170-knot winds, offering some support for gale development. That pushes off to the east into Thursday and starts moderating while winds again start building off the Kuril Islands. In fact, the jet looks pretty good as we get into Saturday night, pushing the whole way from Japan up into the northern Gulf with winds at, what's that, about 160 knots, something like that. But no real troughs indicated until we get into the Sunday night time frame, and then a bit of a broad trough starts setting up here over the north dateline region. The dateline's right here, and maybe that will help support some gale development. But we're a week out by that point in time. And again, the models are not very stable, even 4 or 5 days out, much less a week, so don't take any of that to the bank. So next up, surface level pressure, surface level winds. As expected, the trough off the U.S. West Coast has produced a gale with 35, actually was, I think, up to 45 knots at one point. The second gale in the trough there over the northwestern Gulf still has 30 to 35 knot winds. And then a new gale trying to organize just inland from Kamchatka, not really doing anything yet. But as we get into Monday, the trough off California starts fading, pushing inland. The trough up in the northern Gulf starts fading as well, while we kind of keep our eyes on this one off Kamchatka. And by about Tuesday morning, 30 to 35, almost a little tiny area, 40-knot winds start developing, aimed well at the Hawaiian Islands, getting traction on the ocean surface while falling southeast into Tuesday night and Wednesday, and then moderating some with winds down to 30 knots Wednesday night, and pretty much fading out. And you also notice winds building off California. Little bit of fetch tries to organize as we get into Saturday over the North Dateline region with at about 35, almost 40 knots, and growing in coverage as we get into Sunday, and that should be supportive of some sort of seas and maybe swell development pushing into the northern Gulf of Alaska a week out. So we're going to go back in time just a little bit here. On Saturday, a gale started building over the dateline. This producing seas that were 24.9 feet over a tiny little area. There's Hawaii. Also notice the gale off the U.S. West Coast too. As we get into we'll say late Saturday night, the gale over the dateline built with seas to about 26 feet and 27 feet out here off of California, falling south. You can see the front from the swell already starting to push towards the California coast on Sunday morning, while the system over the dateline starts fading, and that gets us to the current time. Let's go look at the forecast. There we go. As of right about now, 4 o'clock on Sunday, the gale off California falling southeast with 23-foot seas, and then the gale in the northern Gulf fading with 20-foot seas, while the one off to the west tries to get organized. Then finally Monday night gets organized, 24-foot seas, something like that, 24.1 feet to be exact, the highest seas over this entire domain. Start pushing off of Kamchatka with seas still in about the 25-foot range into Tuesday night, then in the 22-foot range as we get into Wednesday and Wednesday night, and then fading out with swell eventually pushing into the Hawaiian Islands. And then the next system starts forming over the North Dateline region on Saturday, 25-foot seas, let's say. Maybe building to 26, and they're 28 feet on Sunday. That's a week out, if you believe that. And then continuing into the northern Gulf. So something to watch. So then let's look at the propagation of these three different systems. Now you go, there's a system off California. Why is there nothing shown here? Because this is actual surf height calculated from swell, not from wind swell. So most of this energy that is in the core of the system is wind swell. It's not till the swell, the raw energy, the seas propagate away from the fetch area that it starts turning into swell. You see little pieces of it there starting to develop, push into California, and being something that resembles real swell on Monday morning, but that's a pretty good indicator that things are going to be pretty raw. You also see the second system, swell, pushing out from towards Hawaii. Now, this is actual calculated surf heights here, so what are we talking? 10, 12, maybe a little bit higher than that, maybe 15-foot surf along the coast, but very raw. Next swell pushing towards the Hawaiian Islands and hitting somewhere around Tuesday night, something like that, and size is in the maybe 8-foot range, something like that. And then that fades out, and then the next system pushes across with energy impacting the Hawaiian Islands, potentially on late Friday night, early Saturday morning, maybe 10-foot faces. Again, this is a rough approximation, not something to take to the bank, but it gives you sort of a way to visualize swell energy pushing into your location and a rough approximation on size. You can actually see the shadowing. Let's go back here. You can see as the swell hits the Hawaiian Islands for locations south of the Hawaiian Islands, you can see the shadowing that the Hawaiian Islands create. So anyway, you get an idea. And then swell energy pushing into California. When is that? The final system on, we'll say Sunday afternoon, something like that, and then we're out a week. Now, the southern hemisphere has started to move a little bit. There was a tiny little swell that hit the Hawaiian Islands. It's starting to hit Southern California. I think it started today. Size really small. It was so small. Like 1.3 feet at 16 seconds or something like that. Maybe 2.5 feet. But waves for sure. Anyway, on last Monday, another system pushed under New Zealand with 33-foot seas. See, it's pushing off to the east. Didn't even last very long. And then tried to reorganize, but again, pushing off to the east. Most of the energy from these sort of systems, they'll impact South America, Peru, that area. But certainly they don't make it well up into Hawaii or even the U.S. West Coast, so nothing is expected from that system. Then we're just going through the past couple days. Another system pushed under New Zealand a day ago on Saturday with like 32-foot seas, but it too was in the same situation, all pushing off to the east. Then looking forward, things are actually theoretically supposed to get a little bit better. Not right now. So there, even by Wednesday, there's some systems off in the far southeast Pacific, but out of the swell window for even California. Then theoretically, right here, somewhere around Friday or Saturday, the models have been sensing something developing under New Zealand. This model, this run of the model, actually looks a lot less encouraging than the past 24 hours worth of models. But as you get into Sunday and Monday, you see some energy building, actually projected to push a little bit more to the northeast. So still kind of early in the year. I mean, in the summer season, it's not even the end of March yet. We're getting some activity down there. That's about normal in terms of the timing, but to expect any significant swell, probably a little bit premature. All right, local wind forecast. We're looking at Hawaii, light trades for now. California, see big low pressure circulating off the coast. There's San Francisco, Northern California, Southern California down there. 30, 35 knot winds. The front, see most of the energy off the coast, falling south. The front sort of glancing the coast, south winds in the 20 knot range right now. So we get into Monday, the low starts moving closer to the coast, southerly winds in the probably 10 or 15 knot range Monday morning. And then the low quickly fades. See high pressure building in behind, northwest winds by, let's go, even say this is Monday evening, northwest winds 10 to 15 knots. And as we get into Tuesday, building to 15 knots, the southeast flow continues for the Hawaiian Islands at about 15 knots. So we get into Wednesday, high pressure, the typical gradient starts setting up for California. Northwest winds 15 to 20 knots. Trades okay for Hawaii, but you see a big bolus of easterly trades just east of the Hawaiian Islands, maybe good for wind swell. So we get into Thursday, northwest winds 25-30 knots, raking all of north and central California, but trades not horrible for Hawaii in the 15 knot range. Friday, again, still this 20, 25, and 30 knot north winds along the California coast. Trades 15 knots for Hawaii. And then as we get into Saturday, more of the same trades, northwest winds for California. And then Sunday, no real change. Winds still nuking along the California coast. If anything, forecast building. Trades not too bad for the Hawaiian Islands, 15, maybe 20 knots, but a good area fetch off the coast here, likely producing easterly wind swell. The all-important precipitation forecast for California right there. Low pressure off the coast. You can see rain just barely starting to glance Point Arena, and this evening pushing into all of North and Central California by about 11 o'clock in the evening, and by early 5 a.m. Monday morning, rain for the entire California coast, even down into Southern California. The focus of it, we'll say right around Morro Bay area, and maybe some snow starting to fall in the Tahoe region in the highest elevations, building as we get into the morning, and by the evening, precip's starting to fade for North and Central California, still holding on for Southern California, snowing in the Sierra, but fading as the evening goes on. By Tuesday morning, a clearing pattern, last lingering showers for Southern California, maybe some snow flurries for Tahoe, and things wrap up. After that, literally nothing is forecast. Not significant amounts of snow expected either for Tahoe. Let's go take a look at that. For Squaw Valley, North Lake, 3 inches, something like that. Kirkwood doing a little bit better, maybe 5.5 inches. And Mammoth also about in the 5-inch range. So every bit of precip up in the Sierra is a good thing. We'll take it. Not a big dump, but at least a little bit. And decent amounts of rain. Yeah, we haven't really looked, but I think the general thought is about a 1/2 inch of rain in the Bay Area, and I don't know about Southern California. Maybe a little bit more, though, it looks like. All that is good. Anything to get precip into the reservoirs, we'll take it. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation and the El Nino Southern Oscillation? As usual, we start by looking for signs of the active phase of the MJO, the Madden Julian Oscillation. There's 2 phases to it, active and inactive phase. The active phase is on one side of the planet, the inactive phase on the other. They rotate from west to east in opposing pairs on the equator. what we're looking for is the active phase moving over the Pacific. When it does that, it's effective. The active phase is a low pressure system. It transports energy up into the upper atmosphere, and that in turn feeds energy to the jet stream, which in turn feeds the development of troughs, which then produce storms and produce surf. Also, the active phase can reduce trade winds. That's a good thing. And if the trade wind speeds and the active phase is strong enough, it can actually reverse trade winds on the equator, which in turn takes warm water that's in the West Pacific, push it east in the form of a Kelvin wave that can then start warming temperatures eventually as the Kelvin wave hits Ecuador, start creating warm waters there, and that can usher in El Nino if you have successive strong active phases of the MJO, which we do not have right now. But it's always a hope and always a dream. All right, so let's start looking for any signs of MJO activity. Right, this is data from the TAO buoy array, a series of buoys strung across the equator. This is the equator right here. That is the East Pacific. That is the West Pacific. That's New Guinea. The date line right there. We're just looking at the arrows. The arrows are wind speeds. On there's wind sensors on the buoys. 5-day average winds. Winds pretty strong from the east. The East Pacific, that's trade winds. Pretty strong over the Central Pacific, so Hawaii would be like 158, 155, so right in up here. But south of Hawaii, trade's pretty strong. And then over in the all-important Kelvin wave generation area, the far West Pacific, when the active phase is over here, this is where you can generate Kelvin waves. This is where you get all your good energy transport up into the jet stream to feed the storm track. Wind's pretty strong out of the east, all this looking like the inactive phase of the MJO. But it's not the actual wind speeds, it's the difference from normal for this time of the year that really matters. So we look at the arrows here in the East Pacific. The arrows are pointing north. They're not really pointing off to the west, so that means really they're pretty much normal. And it's the same thing over the Central Pacific. It's only when you get into the Kelvin wave generation area, that area from about 170 west, 5 degrees north and south of the equator, so right in there, you see the arrows pointing out of the east, so trade winds stronger than normal. Not a whole lot, but a bit stronger than normal. Let's go take a look at the 1-week forecast. Zonal wind anomalies for the whole planet. That's fancy words. 850 millibar rain level. That's about 4,700 feet off the deck. So that's pretty good approximation for what's going on down at the ocean surface. So this is the whole planet on one chart. The date line runs right up the middle. So the West Pacific starts about 135 east, so right about there. It goes the whole way over. California's at 120, and then down on the equator, well, Ecuador is pretty much on the equator, so it goes to right about there. But all we really care about is the Kelvin wave generation area, that area in the far West Pacific. So 135 east to about 170 west, right there, or you can draw the line the whole way up. The blues and the purples are easterly anomalies. The reds are westerly anomalies. Think of this as inactive phase of the MJO, active phase of the MJO. The good news is that you see the blues, as of a day or two ago, disappeared, and now we have light westerly anomalies filling the Kelvin wave generation area. That's good. The bad news is they're only supposed to last for about 5 days. They'll be confined to the far West Pacific, but you see easterly anomalies again starting to build over the date line. Just can't get a break. That's pretty typical, though, of La Nina. All right, so another component of the MJO, we said it was like a low-pressure system, the active phase, and low pressure creates clouds, right? So this is a way to look at the amount of clouds over the planet and try to tease out where the active and or inactive phase is. The inactive phase, by the way, is like high pressure. High pressure clears clouds out, get a lot of sunlight reflecting off the ocean surface. This is outgoing long-wave radiation. Fancy words for cloud cover. So, where are we? We have 4 different panels. Each is 5 days long. There's South America, Central America, Hawaii, New Guinea, the equator. EQ is right there. The date line right there. So this is the Pacific. Kelvin wave generation area right here, far West Pacific, from 135 east out to about 170. Just draw a box right there in your mind, and that's where we're looking. Right now, not a whole lot going on. a weak active phase, this per the statistic model. The CA model is the statistic model. So the active phase building a little bit 5 days from now, but then fading quickly 10 days from now as the inactive phase, dry air, starts pushing into the West Pacific, and the inactive phase in control 2 weeks from now. The dynamic model, I like this one much better. It doesn't show any active phase building, but it doesn't really show much of an inactive phase. It shows up for a day or two, then disappears. So see if we can, there we go. We can get the two of these sort of lined up. So you can see the 15-day forecast from the dynamic model says neutral conditions. The statistic model says strong inactive phase. So we definitely want the dynamic model to be right. Next up, phase diagrams. So this is just another way of showing details of the statistic model and the dynamic model. The MJO moves from west to east from the Indian Ocean. That would be like phase 2 and 3. Actually, it starts over here, like over Africa. Moves and builds while going over the Indian Ocean. This is on the equator. Over the maritime continent like Bali, and then the key spot is in the West Pacific. That's where we want it to be. Moving from the West Pacific to the East Pacific, under the United States, across the Atlantic, and back to over Africa and back to the Indian Ocean. The cycle starts all again. Where the heavy dot is where the active phase is right now. So in the maritime continent, the further the dot is from this circle, the stronger the active phase is. So incredibly weak. And the forecast per the statistic model has it moving somewhere over Africa roughly and exceedingly weak. The dynamic model suggests something similar with the active phase quickly. I mean, like in a matter of a week, moving over to the Atlantic and then quickly crashing back over the maritime continent, and about as strong as it was when we started, exceedingly weak. So the more likely guess is the active phase is just supposed to be very weak, noodling around in the maritime continent and going nowhere, just fading probably. The upper level model showing areas favorable for precipitation. Green is favorable for precipitation, red not favorable. 8 different panels here, each panel 5 days. This goes out 40 days. South America there, Central America there, Hawaii right about there, that one little dot. New Guinea there, the equator there, and the date line roughly there. Today, weak active phase over the Pacific, continuing across and pretty much gone by April 16th, where a strong active phase or inactive phase of the MJO starts building in the West Pacific in early April, makes its way across the Pacific into May 1st, and then another active phase sets up in the West Pacific, let's say the last week of April, pushing to the Central Pacific at the end of the model run on May 6th. So looking at this, you can clearly see the active phase, inactive phase, active phase. If you were to guess at a period when the surf would not be good, it would be during the inactive phase, so roughly from maybe April, the first week in April, through till about the end of April. So April, probably not shaping up to be a great surf month, at least according to this model. All right, the 1 month model, again at the 850 millibar zonal wind anomaly level. The blues, easterly anomalies, the reds, westerly anomalies, Kelvin wave generation area right in here. Now, the one thing this chart shows, this heavy black line, that is the active phase of the MJO. The dotted line is the inactive phase. So you can sort of get the sense it's not completely cohesive, but it looked like the inactive phase just has finished traversing the Pacific. Now the active phase is doing its thing, and it's going to make its way across the Pacific and out of the Kelvin wave generation area by about April 7th, something like that, so about a week or so, with westerly anomalies trying to get set up in the Pacific, but really pretty strong south of California, starting maybe 3 days from now and continuing into the first week of April. I mean, this might be an actual pretty good target for like what we have today, where there's this trough just off the California coast. This sort of pattern would suggest maybe a continuation of that. Maybe we'll get another trough and maybe some precipitation, but that's purely a guess just looking at this. After that, though, east anomalies, the blue are the east anomalies returning. Inactive phase of the MJO starting the first part of April and making its way across the Pacific. So we don't trust a model going out a week, so why would we bother looking on a model that goes out 3 months? Well, when you're desperate, you'll take what you can get. So that's what we're doing. Now, this is the CFS model going out 3 months. Past performance is the bottom here. The one thing that stands out, dateline runs right up the middle there. Far west Pacific starts 135 east, so right up about there. And the end of the Kelvin wave generation area starts right about there, 170 west. Good Kelvin wave formed in good active phase of the MJO produced western anomalies, these yellows and oranges, westerly anomalies. That actually produced a Kelvin wave. We'll talk about that in a minute. And then after that, since the end of January, you just see this complete domination of easterly anomalies, the inactive phase of the MJO, or at least La Nina, and that would explain why there hasn't been a whole lot of activity in the North Pacific this winter. But you notice, starting right today, there's a marked difference in that, yes, there are still some easterly anomalies, but notice as we get into the late part of April and May, what was this permanent ball of easterly anomalies that was on the dateline is now to shift to a point maybe just off the California coast, and you see westerly anomalies taking over the entire, or almost the entire Kelvin wave generation area, suggesting that La Nina might be fading. In fact, let's overlay the MJO here. All right, so here's what's going on. The solid red line is the active phase of the MJO. It's in control of the Kelvin wave generation area today and forecast to be traversing the Kelvin wave generation area. Where you're just going to ignore this dotted line, probably say the whole way into May, some sort of an active pattern in control with westerly anomalies in control. And then you see, even after that, as we get into mid-May or so, this dotted contour, the inactive phase of the MJO setting up, but with westerly anomalies persisting to right about there, let's say. So if you go straight down here, that's like 175 east, almost to the date line. To me, that suggests a significant change versus what we've been seeing the past 2 years, which is easterly anomalies filling the Kelvin wave generation area. Now, light westerly anomalies forecast creeping into the Pacific. Too bad that didn't happen back in October, but I'll take it now versus, not having this at all. Hopefully it will hold. Let's overlay the low-pass filter. This will explain some of what's going on. The dotted line here, this is a high-pressure bias. Think of it as where the core of La Nina is. And you can see back in December, it was right smack over the date line, 180 west. But now you see starting today, well, it's down at 150 west, south of Hawaii. And as you move in time, you see the leading edge or the trailing edge of it starting to ease off to the east some. And what's even more interesting is this dark line here, the solid contour, is the low pressure bias. Think of it as the El Nino indicator. Well, if the West Pacific is here, you can see little bit at a time, the low pressure bias is easing into the Pacific as we get into June, theoretically. That should be, at least as far as we're concerned from a surf perspective, the demise of La Nina, with low pressure setting up over the West Pacific as we get into next fall. Then theoretically we should be in a much better place than we have been the past 2 years. So then that brings us to the El Nino, La Nina part of the discussion. All right, we're looking at subsurface water temperature. So El Nino, La Nina, it is a coupling of the ocean and the atmosphere. In La Nina, you have cooler than normal waters in the Pacific. That in turn suppresses evaporation. That in turn creates high pressure over the Pacific. And that in turn brings dryness, drought, and lack of storm generation potential. Likewise, when you have warmer than normal waters over the equatorial Pacific, then you get more evaporation that supports low pressure, and then you have your typical La Nina sort of symptoms. All right, so let's start by looking down in the ocean. West Pacific here, East Pacific here. We're going down 200-300 meters. That's 600 or 900 feet roughly down. Okay, these little hashed lines here are actually the anchor lines on the TAO buoy array, those buoys strung across the equator used for monitoring El Nino. The X's are sensors on the anchor lines. The sensors read subsurface temperature data that gets relayed to a central process facility. You take a model to fill in the gaps, and you get a profile of where your warm and cold water is under the surface of the ocean, not on the surface. And remember, warm water supports evaporation. We want to see warm water building in the East Pacific and Central Pacific. So interesting, last week, the 29-degree isotherm, or the 28-degree isotherm right here, that's 28 degrees centigrade, that's warm water, that's 80-plus degrees, had backtracked to, I think, 65 east or maybe 68 east past day or two. Now it's pushed off back to about 172 east, so warm water moving east a little bit. We want to see that. Also, the 24-degree isotherm, at one point, it was almost touching the surface here, I'm saying just like maybe 2 or 3 weeks ago, and all this winter, the 24 isotherm never made it past 140 west. Now, all of a sudden, it looks like we're getting some thickening of warming water here, suggesting not a Kelvin wave necessarily, but just a general base state of warming developing subsurface in the Pacific. But it's not the actual temperatures, it's the departures from normal for this time of year that really matter. Warmer than normal water, 3 degrees centigrade, under the equator, making it to, what is that, 160? Yep, 160 west, so just a little bit over the date line. This had actually been retracted about a week or two ago, too. Now it's starting to not really move, but just sort of ease east a little bit. A previous Kelvin wave from that westerly wind burst we saw back in January is still lingering in the far East Pacific. Notice here, though, cool anomalies, now down to 2 degrees building in between the two cool pools. So this is a little bit interesting. If westerly winds don't build significantly and create another Kelvin wave and start taking this warm water and pushing it east, then the likely result will be a building cool patch again here in the central to southeast Pacific, which is sort of the pattern we've been in for a while, indicative of La Nina. This other model suggests the cool pool is actually even deeper than what the previous one suggested. It'll go, let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 4 degrees below normal here, where the other model said maybe 2 degrees. So a bit of a difference. There's the last lingering bits of the previous Kelvin wave, and a Kelvin wave that wants to happen, but it needs a strong active phase with westerly anomalies to start setting this warm water in motion to the east. Sea surface height. These are not temperatures. This is the height of the ocean, the sphere of the ocean for the Pacific. In fact, let's get oriented here. Chile, Peru, Central America, California up there, Hawaii right there, equator right there, dateline right there. You see positive anomalies, 20, 10, 15, 25. These are, the sphere of the ocean is a little bit higher than normal. Warmer than normal water at depth expands, creates a bump on the ocean surface. Cooler than normal water at depth contracts, creates a divot on the ocean surface. That's what we're seeing here. Minus 15 centimeter anomalies south of Hawaii on the equator, suggesting cool water at depth, a little bit off the coast of Ecuador here, but most warm water balled up in the far west Pacific. Upper ocean heat anomalies. So this sort of gives you the historical picture of what's been going on. West Pacific here, East Pacific here. Time, we're going back a year, April 2021. Yellows and oranges, warmer than normal temperatures. Kelvin waves, 1, 2, 3, pushing across the Pacific until July of last year. Notice the warm pool in the west just all tapped out. It collapsed. Trades built. Upwelling started occurring, and this set us up for the second year of La Nina, pushing into December, into January. We got a westerly wind burst associated with the active phase of the MJO in the January timeframe. Kelvin wave has pushed across the Pacific, the last little lingering warm water from it off the coast of Ecuador today, and here we go again, another bit of warming. Though this time, notice, there's a pretty decent amount of warm water over the West Pacific still. It's not like the warm pool got completely tapped out from this 1 Kelvin wave. So there's hope that if we got a decent active phase, maybe another Kelvin wave would set up. And some of this, though, is just the bias in the atmosphere, the high pressure bias we talked about earlier, and just a proclivity to continue to generate easterly trades. As the high pressure bias moves east, the tendency to do this will lessen. As the low pressure bias move east, this warm pool will start moving further east as well, and then we'll be in a much better place to support energy transport in the jet, to support storm development, and to get some precip into California. Surface temperatures right here, 4 panels, sort of a mosaic stitched together. Let's see, Chile, Peru, Central America, Baja, California up there, Hawaii there, the equator roughly right there. The blues, so this is sea surface temperature anomalies, differences from normal for this time of year. A clear, cooler than normal water signature over the equator. Developing, it's off of Peru and Chile, but there is a little bit of warm water along the coast here. What's really interesting, though, is this warm pool here. This is the Kelvin wave that erupted starting maybe 3 or 4 weeks ago off of Ecuador and the Galapagos right there. That warm water still gurgling up to the surface, getting caught by the trades, pushed off to the east, so it's making it out to about 130, 135 west right now, so past California, and will continue to push its way off to a certain degree as long as there's sufficient warm water at depth so this doesn't get too diluted. Theoretically, it could fill the Pacific, but it probably won't because we know the Kelvin wave isn't that strong, and we know you need multiple Kelvin waves in quick succession so that this pattern just keeps going and so that the warm water traverses the Pacific and fills it up, and then you get atmospheric change. You get more evaporation as the warm water holds, and once the atmosphere senses that warm water is going to hold for a good amount of time, then atmospheric changes start happening. We're not suggesting any of that's going to happen given where we are, but what we have is a lot better than where we've been. Sea surface temperature trend for the past 7 days. So you can see here is the warming temperatures on the equator, and that's all we care about is what's going on at the equator. Warming water up here doesn't do a whole lot. They're more like symptoms of what's happening on the equator. So we had a good amount of warming last week, all in this area. You see the blues, it's cooling, suggesting the Kelvin wave is pretty much tapped out. The remnants of that Kelvin wave are traversing across the Pacific like what we saw in the previous picture, and they will probably get diluted as they continue east. So we're probably in as good a place as we're going to be for a while right now. The backed off view, same sort of thing. Here's your warm pool, your Kelvin wave eruption off of Ecuador and the Galapagos. Your pre-existing La Nina condition, high pressure in the northern hemisphere rotating clockwise. You can see the upwelling pattern along California working its way down here. Same things happening in the southern hemi, high pressure rotating counterclockwise, creating upwelling, all of it pushing off to the West Pacific. You have to get the high pressure bias further off to the east so it can't get as much traction, and you have to get the low pressure bias. Well, right now it's barely in the Pacific, somewhere down around in here. You want to get the low pressure bias over to about here, at least to the leading edges over the dateline or so, and then we should see significant challenges to this cool pool and perhaps the end of it and the end of La Nina. But if that were going to happen according to the model we just saw, probably won't happen until the June-July time frame. But that model is a bit optimistic, so kind of unknown right now where we're going to end up. Nino 1.2 index, sea surface temperature anomaly index. You can see, and this is the area right off the Galapagos and Ecuador and that area. Sea temperatures have been steadily rising, and then now they're starting to fall again. right about dead even, 77 thousandths of a degree below normal. Not too bad, but this is pretty much expected. The Kelvin wave peaked out. Now it's starting to fade, and we would expect to see these temperatures falling. Likewise, the Nino 3.4 index. The Nino 3.4 area is that area south of California on the equator out to about the date line. We saw warm water starting to move into that area. Sure enough, temperatures are on the rise. 685 thousandths of a degree below normal. Half a degree below normal is the La Nina threshold. So we're still clearly in La Nina territory, but we're making an attempt to try to get closer to normal. We did the same thing back in January and February when there was a Kelvin wave. There was some warming activity going on there as well. So temperatures warming a little bit, but still clearly in La Nina territory. And like we said before, El Nino and La Nina are this interaction of the ocean and the atmosphere. We can actually measure that interaction. Difference in pressure between Darwin, Australia, and Tahiti. Darwin roughly in the Indian Ocean maritime continent. Tahiti certainly in the Central Pacific, Central South Pacific. They both have long-running pressure records. So you can simply integrate the difference between pressure between the two and get a sense of, is pressure higher or lower than normal in the Pacific? If pressure is higher than normal, you get this positive index. Today, 11.49. Looking back over the past month, just like it's been every other month for the past 2 years, positive, indicative of La Nina. But that's kind of a noisy index. You see it's 11.49, then it's -1, then it's up to 21. So you do a 30-day average over that number. That takes some of the noise out. Today, 13.46. And that's actually, I think, the highest this index has been this entire winter. So according to this index, we're at the peak of La Nina right now, and we're in March. Still, last year we were up at +19, so we're not as bad as last year. The 90-day average is the El Nino La Nina indicator, 7.9, actually going down a little bit, but pretty much unchanged. It's just steady state, weak La Nina situation. Pretty much an impenetrable brick wall of high pressure over the Pacific is what this indicates. So where are we going? Well, the Nino 3.4 sea surface temperature anomaly forecast from the CFS version 2 model suggests, well, today we're in March, so somewhere here. Temperatures about 1 degree below normal, and according to this model, falling to almost 1.35 degrees and then noodling around there for the foreseeable future. But there's some issues with this model, so they have a corrected version of it, but it doesn't help too much. It still suggests temperatures holding 1 degree below normal into December of this coming year, so that's 9 months out. So still clearly in La Nina territory. Again, the cutoff, half degree below normal. If you're below that for 5 consecutive 3 months periods, you're in La Nina. This model says that is the case. Looking at all the other models, there are both dynamic models, there's a bunch of them, and statistic models, and you can lay this all out on a grid. And the consensus of all these models, and one of those, there it is, the CFS model, that's the one we were just looking at, which is there, the lowest of any of these, you see. But the consensus is the CPC consensus suggests returning to neutral in the October time frame. The dynamic average suggesting, well, maybe down 0.31 of a degree, a third of a degree below normal. In fact, let's go down here and just look at the raw data. So here is the dynamic models, and we'll just say -8 right now, slowly working our way to maybe a third of a degree below normal as we get into October and November, but still somewhere between almost a half a degree from July onward. The statistic models, a little bit more positive, suggesting almost a return to near neutral as we get into, the October-November time frame. So the real question is, are any of these models right, or is the CFS model, which, again, we'll show it right there, there it is, which seems like the cold outlier, it and the NASA GMAO model are both pretty well down there. And then there's this one other one. So 3 out of about 30 suggest staying cold. Everybody else is kind of grouped around a neutral. We're in the spring unpredictability barrier, or just about there. So some of these models have a hard time getting a handle on what's going on. So for right now, swell looking to be arriving at California tomorrow. Pretty raw, though. A little bit of southern hemi-swell probably mixed in as well. Hawaii, series of swells forecast. Nothing huge for the 2 different ones. And some of that energy reaching into California as well. So the northern hemisphere is not done with its push for right now. Winter's still in play, but pretty weak. Southern hemi trying to come online. Nothing really solid yet. I mean, yes, there is some small southern hemi swell lapping into the best spots in Southern California, but no wholesale sail, real swell forecast from the southern hemi just yet, but we're going to keep our eyes on it. We'll keep looking. Longer term, well, kind of looks like, at least for North and Central California, a lot of north winds. Maybe a little bit of rain and a little bit of snow, but not too much. We'll try, keeping our fingers crossed. Every little drop counts. We'll take it. Looking out beyond that long term, officially the models are saying La Nina again, potentially, at least some models, as we get into this coming fall. But a whole bunch of other models say not. The spring unpredictability barrier runs from starting in around April somewhere to about the end of May, maybe the early part of June. Models have a hard time getting a handle on things. We'll see where we are then. Theoretically, by then, the low pressure bias should be moving deeper into the West Pacific. And if that's the case, and the model verifies, then hey, we could be in a much better place as we get into next fall. That said, 2 years of La Nina has set up upper level wind currents that are not easily going to change. It's going to take months for the global weather pattern to change, assuming it does change. And that's sort of part of the issue with, once you have momentum in a particular direction, if nothing significant happens is to shake you out of that condition, you stay in that situation. And I think that's what some of the models are cluing on when they're suggesting La Nina for next year as well. Way too early to know. We'll just have to see. Anyway, if you enjoyed the video, give us a thumbs up, like, or subscribe if you haven't. There's a little icon down there in the lower right-hand corner. Click on it. You get automatic notifications when the video's been updated. And comments always welcome. We try to respond. We get a lot of good questions. So if you have a question, pipe up, let us know, and we'll do our best to try to answer it. All right, that's it for this week. We'll do it again next week, same time, same channel. And thanks for watching.